All right, here is the first problem of our quadratic section. Connor and Spencer want to race each other on a 500-meter dash. Connor runs at 5 meters per second the entire way. But Spencer thinks that slow and steady wins the race. He starts at a slow 0.5 meters per second and accelerates at a steady 0.5 meters per second squared. I want to know A, what is Connor's time? B, what is Spencer's time? And C, who won? So, this is going to be a two-part problem. So let's go ahead and define two sets of variables. We have Connor, and we have Spencer. Connor's going to have his own S, XI, VI, VF, A, and T. Spencer is going to have an S, XI, VI, VF, A, and T. All right, listing out our equations. S equals XI plus VIT plus 1/2 AT squared. And A is equal to VF minus VI over T. Now our first step here, get all of our information squared. Each of them are starting at the same point and moving 500 meters. So they're going to have the same S and XI. That's how a race works. So both of them are going to have a starting position of 0. Both are going to have an ending position, 500 meters. Connor runs 5 meters per second the whole way. So if he runs the same speed the whole way, his velocity final is going to be that same 5, and his acceleration is going to be 0. Then all I have to solve for is T. That'll be nice and simple. Now, some of you might say, well, I mean, I've got VI, VF, and A. Might as well use the acceleration equation to solve for time. But that's not going to work, because this isn't just straight math, this is reality. And in reality, if we have no acceleration, we can't use that to figure out our time. We're going to have to use our velocity and distance formula to find our time. Now Spencer, a little bit of a different case. He starts at 0.5 meters per second, and he has an acceleration of 0.5 meters per second squared. We don't know his VF, we don't know his time, so we're going to have to use the same S equation to solve for Spencer. So let's go ahead and figure out Connor first, because he's nice and simple. S equals XI plus VIT plus 1/2 AT squared. His acceleration is 0, so drop that right out. His starting position is 0, drops it right out. It gives us S equals VIT. Beautiful. So 500 is equal to 5T. Well, divide both sides by 5. 500 divided by 5 is 100. It takes him 100 seconds to run the 500-meter dash. That's a little over a minute and a half. Great. So now, Spencer. Now we have a different case here. I have an XI of 0, so I can get rid of that. But I have a VI of a positive number, A of a positive number, so let's go ahead and plug everything in and see how it works out. Well, 0.5T plus 1/2 0.5T squared. Now some of you might go, well, T squared, those are basically the same thing. I can just merge this together. Let's just add them together and then we're done. It's great. But T and T squared are two separate variables mathematically. I can prove that by saying, okay, let's pretend that T is 2. So if T is 2, then T in this part would equal 2, and T squared would equal 4. Well, that wouldn't work then, because those wouldn't be the same thing. We couldn't just merge them together. They're two distinctly separate numbers. This is what we call a quadratic formula. And if we were to set this equation up and then graph it, we would get a graph that looks something like this. Okay? So this U shape could move up, it could move down, it could move left to right, however it could move on this graph. But ultimately, we're saying with these variables plugged in, we're going to get some certain number. On this point, we're going to get two variables out of it. Does that make sense? At some point, 0.5 t squared and 0.5 t and 500 are going to give me variables at a certain point along the y-axis of this graph. And I'll have a result of two values on the x-axis of the graph. So we're going to set up our quad form. If your calculator does not have quad form, if you don't have a graphing calculator, get one. And if it doesn't have quad form, you need to see me immediately so we can get it on there, we can get you moving. If you don't have a graphing calculator, there is another way to solve this by hand, and it's a huge pain, and you're going to hate it. So get a graphing calculator. All right, moving on, because I have a graphing calculator, I'm not going to go through that trial and tribulation of using the quadratic equation. I'm just going to punch this in my calculator, but first I have to get into the right form. Now, some of you might have a very nice, fancy, old TI-89 where it already has a solve function installed on it, so you can just punch in your equation, no matter what kind, and it'll go. But most of you have a type of calculator that requires a program. This program is called quad or quad form, and it requires you to insert these numbers one at a time. So we need to set our equation up in quad form. So the way that has to look is our equation has to be equal to 0. So we need to move this 500 over here so that this side can be 0. So we're going to subtract 500 from both sides. So it's going to get me 0 equal to a negative 500 plus 0.5t plus a 1/2 times 0.5. We're going to simplify that right away. 0.25t squared. Okay, now we have this set up, and what we're going to have for your program is each of these terms is going to be one part of that program. It'll ask you for an A number, a B number, and a C number. So your A number is going to be the value that's with the t squared. Your B number is going to be the value with just a regular t, with no square on it. And your C number is going to be the constant that doesn't have a variable with it. So if you're going to punch in quad form, it is going to ask you for an A, you're going to give it 0.25. It's going to ask you for a B, you're going to give it a 0.5. And it's going to ask you for a C, and you're going to give it a negative 500. So let's go ahead and punch those in. So we are going to get two values. T is equal to either 43.73 or it is equal to a negative 45.7. Whenever we're dealing with a quad form problem, we have to take the time and think about which t value is correct. Our calculators will not tell us. The math will not tell us. That is a limitation that physicists have the great fortune of being able to apply reality to. Mathematicians are stuck with having two values. They don't know which one it is. We know. Time cannot be negative. So we know for this problem, it is not negative. We will encounter problems where we will get two positive results. But in those types of problems, if we look at this graph, it'll look something like, I'll just show you in a quick example. We might have something that looks like this. And all of our motion is from this point to this point. And we have these two variables. Our variable for time couldn't be past the end of our motion. When we get to those examples, it'll make more sense. If this is confusing, that's normal. All right, so we know that our time for Spencer must be 43.73. seconds. Boxing around our answers. And who won the race? Oh, that is a clear victory by Spencer. Apparently, slow starting speed and steady acceleration is going to win that race.